Hi there, everybody. This video continues our journey into volumes. Unlike the previous video where we were doing cross sections, for the next kind of 3 days, you're going to be looking at volumes or solids formed by rotating an object around a certain axis. This first method is called the disk method. We are, in this case, we're taking y equals x squared, or the region bounded by y equals x squared, the y-axis, and the line y equals 4, which is this, and we're rotating it around the y-axis. And we get kind of a shape that looks like a bowl, which you can kind of see here, as I've drawn it. And this is the disk method, so we're kind of imagining dividing this bowl up into really skinny disks. Now, let's back up a little bit, talk in general. For the disk method, since we're using disks and we're rotating an area around an axis, the volume of that disk is always going to be the area of the top in this case times the thickness of the disk. Now again, since we're rotating it, the area of the top is always it's always a circle. So the area is pi r squared. And the thickness is d something. Sometimes it's x, sometimes it's y. I'll show you in a second how to figure that out. And then we add the volume of all those disks together. The integral does that. So this is kind of our general formula for finding volumes using the disk method. Now, of course, we'll have bounds here, and if this is dx, this will be bounds for x. If it's dy, these will be bounds for y. We also won't have r here. We'll have something in terms of x or y, but that's the radius of the disk, and we'll see how to figure that out, or what that is in terms of x and y in a second. Let's take a look at our example. So first thing we need to figure out is, are we integrating dx or dy? Now, the d part of this, the d whatever, is the thickness of the disk. In this case, our thickness of our disk is this way, which is a y. It's kind of a delta y. It's a change in y. So that means we are going to be integrating dy. Now that also means that our bounds are for y. So we're going from 0 to 1, 2, 3, 4, 0 to 4. Now pi r squared is the area of a circle. So pi, now our radius is an x coordinate. But we need this radius, sorry, x squared. We need this radius in terms of y because we're integrating dy. Well, so we've got to solve, if you solve this for x, you get the square root of y. So I'm going to put the square root of y. And so the square root of y is our radius. That's an x coordinate, right? If you solve this for x, you get x equals the square root of y. And this x coordinate is the radius of our disk. It goes here. We're squaring it because pi r squared is the area of a circle times by the thickness of the disk, and the integral from 0 to 4 adds them all up. And so there's our integral that gives us the volume. And we can do this one. This one's pretty easy. The square root of y squared is just y. So what we get is pi times y squared over 2. Right? The antiderivative of y is y squared over 2. We got the pi. We're going from 0 to 4. And so let's see, pi times 4 squared over 2 minus pi times 0 squared over 2. And we get, let's see, 16 pi over 2 is 8 pi for our volume. Easy as pie. Let's take a look at another example here. So this time we're rotating around the x-axis. So our disks are kind of going vertically. And now remember, the d part of this, the d whatever, that is the thickness of our disk. Here's one of our disks. So in this case, that's an x quantity. So that means we're going to be integrating dx. Now this is y equals x cubed this time. And it's the region that we're rotating is the region bounded by y equals x cubed, the line x equals 2, and the x-axis here. So it's kind of that. We're rotating it around the x-axis to get kind of like a, looks like a horn kind of. Again, the thickness of the disk is an x quantity, so we're integrating dx. That's the thickness of the disk, dx. Delta x here because when you integrate it makes them infinitesimally small. That's the dx. That means our bounds are going to be for x, 0 to 2. The disk method, so pi r squared. Now the radius of our disk is a y coordinate, right? Distance from here, from the x-axis to here is a y coordinate. So it's pi r squared. But we need it in terms of x. Right? We can't have a y here when we're integrating in terms of x. So we need to write y in terms of x. Well, that's just x cubed. X cubed. And there is our integral. That'll give us the volume of this horn. Let's see. So that's the integral from 0 to 2 of pi times x to the 6th dx. So that's pi x to the 7th over 7 from 0 to 2. Taking the antiderivative, plugging in 2 now. 2 to the 7th over 7 minus pi times 0 to the 7th over 7. 2 to the 7th is, what, 128? Yep. So this is 128 pi over 7. This part being 0. And there is our volume.